Okay, hello everyone. Welcome to another session on Code Jam. Melody, what's up?
I'm good. How has it been, Oliver?
Yeah, it's been cool. It's always great having to catch up again and trying to build something wonderful or learn something wonderful. So I think this week has been awesome for me. Not that stressful, but that kind of stress. You say, okay, at the end of the day, you benefited something. Maybe you learned something new and all that. So that's actually how the week has been for me. Yeah. So how's it been for you?
Well, I had a couple of deployment myself, so it has been, I think, stressful, but nonetheless, I made good use of the week and I learned a
Oh,
couple of things. So yeah,
okay.
it's a win-win,
Yeah.
right?
Yeah. That's right. So for me, I think what I did was I'm like I love building things like all these the do it yourself things. So I had to like pick up a microcontroller and I wanted to like connect it to the cloud and this ESP32 microcontroller. So I was able to um, pull in some boiler code and try to connect it to the cloud. Though I run into some blockers because of the microcontroller has some issues with the serial connector and all that. But because of that, I had to order a new one, just to keep building. So that's how the week has been. I think that's something amazing I did. It's been a while get to lay my hands on any microcontroller.
Yeah, that's cool. Myself, I started looking at Gates and I started looking at the entire Gate structure and everything, and I got to figure out a couple of things I don't use in my everyday life, and it
Okay.
was cool knowing those things. And I know some of these things have been there, but I don't use them in my everyday life. And sometimes
Yeah.
I go through the long
Yeah.
routes to get something done, which is not the way forward.
Okay. Okay. So let's jump right in. Today we'll be talking about something really interesting. We'll be discussing GraphQL. GraphQL is actually I still remember the last time I had a talk. I was giving a talk on GraphQL. I think that was during DevC thingy. If you've ever attended any DevC events, so it's actually something I can trust me. I love GraphQL. And today we'll be discussing GraphQL. First of all, we'll go through some theoretical concept of GraphQL, trying to explain what GraphQL is, what kind of problem GraphQL is trying to solve. And then Melody will then take over and then build something with GraphQL for us. Okay, so let's jump
Yep.
right in. Yeah, so first of all, yeah,
Now I'm very fascinated about GraphQL and the graph nature
yeah,
of the entire structure. So it's something that intrigues me a lot. And just any day, anytime, I think I'll build the GraphQL over some other technology out there. Well, that's very an
yeah
opinionated.
that's based on personal preference though. But maybe after this call, we get to like decide on which do you think is better, REST or GraphQL?
We could do that.
All right, so let's just go in. In front of us here is my beautiful slide. So, all right. So first of all, before we even talk about GraphQL, discuss what GraphQL is, let's look into understanding what an API is. GraphQL API, right? So it means API means something, right? So APIs are a set of rules. APIs are a set of rules and protocols that allows different software applications to communicate and interact with each other, right? So every software component has um, every software component has things they actually hold in, things that they wish to things that they wish to share out or communicate, right? That is, you want to you're definitely building a software that has to communicate with some system, receive instruction from some system, some other system somewhere, and act on those instructions, right? So API acts as a layer of exposure on which a different component different from that particular application can communicate and talk. They can easily they can share resources, right? So it defines the method and data formats that applications can use to request services or exchange information, which is what I was trying to explain. So APIs are just, you can think of it as a middleman that provides an interface where two software components can interact with each other. All right. So APIs enables developers to access the functionality of a system, service, or platform without having to understand its underlying code or internal workings. Right. So I could drive an example from an integration I worked on recently. So I was actually building an application that integrates with HubSpot. So HubSpot is a CRM tool. And Hotspot is not in my organization, it's in a different organization entirely. But I needed something in their server. I needed my server to communicate with Hotspot. Maybe when a user signs up, I want to update a customer record, right? So how would I be able to communicate with Hotspot server? It's through an API. First of all, I had to Google and go through Hotspot documentation and looked into how I can communicate with Hotspot through their API. So APIs are just what enables developer access the functionality of a system or platform without having to understand its underlying code or internal workings. So I don't have to know how hotspots work or how hotspot servers are set up. All I need to know is okay, I just lay my hands on their API. Their API, first of all, will show some kind of a specification on okay, what endpoint to call, what method to call it, and what data I should expect to receive. Right. So that's what APIs are.
So
So
could we consider
next,
APIs as gateways? Could we say APIs are like gateways to
yeah,
uh,
gateways are like a broader picture. Gateways could contain more than one API. You could have a gateway that connects to different APIs at the back, depending on what request is made. Right.
okay,
So I could be building a decentralized application where I have an API for different services. Right. I have an API for user service authentication service. All right. So all those I connect it to my gateway because my gateway would then expose one URL where anybody that hits that URL, the gateway knows how to route that request to the right endpoint or right API. Right. So you can think of a gateway as a broader, like it encompasses a lot of APIs all coming together to form one.
all right, awesome.
Okay, so next let's then look at what GraphQL is. But before I talk about GraphQL, I'll talk about something we all know, which is REST API. So we have APIs in web development. We have different kinds of API. We have REST. REST can be using a data format like JSON or XML. We have SOAP, and we have commonly GraphQL. We also have gRPC, right?
Yep.
So ROPC or gRPC, right? So now what we're looking at is let's compare something like REST, which is very common. REST stands for Representational State Transfer, right? REST API. That is, you make a request for a particular asset, giving it an endpoint and a method, maybe post, get, or puts, right? Once you do that, depending on the method, then the API responds with some data, right? Now we have REST and we have GraphQL. GraphQL comes to solve some problem or some downfalls or pitfalls of like REST API. Some things REST API can do correctly. GraphQL comes to, depending on the use case, GraphQL comes to make that better, which is what we'll be looking to shortly. So GraphQL is a query language for APIs that offers efficient data retrieval and flexible queries. So that efficient there is a keyword, right? Which is you want to make requests, you want your because each request you make to your server adds some form of load to it. You want to make sure that those requests are made in an efficient manner, right? Where you're calling the server only when you're supposed to be calling it. Right? GraphQL allows the data they need, reducing overfetching and underfetching, right? So that is actually the secret ingredient. That is what makes GraphQL what it is. Being able to retrieve data exactly what you need and how you need it, right? So with GraphQL, as opposed to REST, I can define how I want my data to be returned. I don't have to just make an endpoint and the server decides to either send it or send it in the data format I expect or not, right? Because now, what I've noticed with REST is sometimes different engineers could be working on a particular feature. The back end guy will go and do things, and before you know it, on the front end is broken because the back end is sending some data formats that the front end is not aware of or is not even requesting. All right. So GraphQL is strongly typed. It has a strongly typed script schemas, which enables data integrity and simplifies interaction. It's also ideal for web and mobile application. So I've worked with GraphQL a lot, and I can tell you the downfall and the benefits of working with GraphQL. Okay, so let's move further. So why should you consider GraphQL? Let's pinpoint it, because before choosing a technology, one of the major things you should look out for is why should you even use this thing in the first place? I have REST. Why should I even go and learn GraphQL? Now, before I even talk about why you should choose GraphQL, let me debate a bit. GraphQL, the knowledge of GraphQL has actually made, because I've had some experience interviewing people for a particular role, because they are not knowledgeable, they don't have experience using GraphQL. They couldn't make it cross. They couldn't get the role because that's how important it is now for companies. All right. So let's jump in to see why we should choose GraphQL. Now, first of all, GraphQL provides a single endpoint. As opposed with REST, for each service, each domain you're trying to get, maybe users, or depending on how the backend is structured, you know that you'd get different endpoints. You get one base URL, and each endpoint is pointing to a particular resource. All right. So, and each endpoint also, you need to make sure you're specifying the right method, either gets, either puts, either patch, either post, right? Depending on the action you're trying to perform. Right. So with GraphQL, you don't have to manage several endpoints. Your application don't have to keep track of the right endpoint. You just have one endpoint. Okay. And also, GraphQL is strongly typed. GraphQL introduces type into your system. So before you interact with the GraphQL API, whatever client library you're using would first of all introspect the schema and see what kind of data formats your API is exposing, or your GraphQL API is exposing. With that strongly typed nature, you'd see that on the front end, you wouldn't be making use of any data that wasn't exposed by the front end. Sorry, by the back end. All right, so it's strongly typed. You can think of it like the thing you see when you're using TypeScript, where when you're trying to make use of an object, if that object has a different type, and you try to use it, it will tell you that there is a type error, or you see a type error. So that kind of thing is built into GraphQL. Right, GraphQL itself is a specification, but with the specification given by GraphQL, right, um, frameworks and libraries like Apollo and Apollo clients are able to like ensure that the types defined on the backend are also the types defined on the front end. Right. So GraphQL was actually created by Facebook in 2012 and then open sourced in 2015. So you could imagine if a company like Facebook is able to think of it like, look, there is a problem with REST. Let's create something like GraphQL. Then it's worth adopting. All right. So next, GraphQL reduces API request round trips because of the way REST is. If you fetch a user's profile, you want to make another request to fetch the user's posts, and you want to make another request to fetch each comment inside a post. But with GraphQL, it's just one request. You indicate that you want a profile, you want a user, and inside that user, you want a profile. Inside that profile, you want to get all the posts, and inside all the posts, you want to get all the comments. That means you're just in your front end is just going to um, execute one request, make just one request to the server. So the server doesn't have to like keep trying to process different requests, because each request takes up a lot of packets, including knowing that most front end application uses HTTP, which includes other additional packets to those requests and increases the byte size going through your network and to your server. All right. So also GraphQL offers better development tools, as I said before, with the likes of Apollo GraphQL and other tools out there. You'd see that once you're using TypeScript, everything is hooked up together. Once anybody or the backend engineer comes up and make a mistake or changes something, it automatically reflects on the front end that, look, the schema you're having on the front end doesn't actually correspond with what's on the back end. Okay. Also, GraphQL tries to enforce structure, because first, when you're declaring types, when you have a schema, you see that there is some form of structure. You can define some kind of relationship between each type and each data points and all that. All right. Also, GraphQL provides documentation. I love this a lot. Whenever I'm building a REST API, one of the challenges I go through or face is I would have to think of trying to use something like Swagger to like create documentation, and I would start mapping through every endpoint and try to show what data you should return. But when it comes to GraphQL, there's something called the playground. So once you open the playground, you'll be able to see the schema, and each schema you can actually see what data I return. So me as a front end person, I don't need to bug or bother the backend engineer. I just need to open the playground. I would see, oh, okay, if I go through the node profile, I can actually see the comments associated with a particular profile. It's straightforward. As opposed with REST, where you have to go through the documentation and look for, okay, what endpoint should I call to get a profile, and what endpoint should I call to get the comments associated with a particular profile, for instance. So these are a few reasons why you should consider learning GraphQL or using GraphQL for your project. Because also this, when you look at these things, if these problems are solved at the end of the day, the business or the company you're working for or you're looking to work for, they're minimizing cost because the time spent equals to money. All right. So all right. So while we've looked at benefits of GraphQL, we've talked about what GraphQL is. The next thing we need to look at is common terms. Because we're building something today, we don't want to like throw everybody off. So we want you to be aware of these terms. So when you see us use these terms, you know that, oh, they are referring to these things. So the first one is a field. What does a field mean in GraphQL? What does a type? What does types means in GraphQL? What is schema, query, mutations, subscriptions, and resolvers? Okay, so first we'll discuss field. A field is a single entity of a certain type. They could either point to another defined abstract type or scalar type. So we're talking type, 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 type. Some of us are JavaScript, we've been writing JavaScript, so we don't write TypeScript where we declare types. But when it comes to GraphQL, you need GraphQL works with types, to properly understand what kind of data you want, right? So in GraphQL, there's something called types, which we'll get to explain. But if you look at the image on the right here, you see that we're having a type called project. All right. And project has fields. You could see that project has name, tagline. Right. So those are called fields. Each of those things are called fields. And you could see that here we have a field that points to a scalar type. So a scalar types are like your integer, your string, your boolean. Those are scalar types. While your abstract types are those types you yourself define. Right? So something like on the right here, you can see that we have contributors, and contributors is pointing to another type user. So those are abstract type. So a field could either point to a scalar type or an abstract type. Okay, so here on the right here from the image here, we see that we have a type called project, and project has three different fields. Okay, so next we have type. So as I explained type, a type simply describes what kind of data to be returned, right? You can see that we have a type here called project, and project returns some fields, which is the name, the tagline, and the contributors. These are the kind of data the type return. And most times when you create types, you're actually creating an abstract type because you're creating a type, a custom type that you define what data you should return, right? So types can either be scalar, which are those types that are already defined by the GraphQL schema, GraphQL by GraphQL itself, right? So like string, integer, float, boolean. Then you have the abstract type, which are users defined type, right? Just as what you can see here, project is an abstract type, and also user is an abstract type. Okay, so after we've talked about fields. Fields is just a particular thing inside a type. Then now we're looking at schema. A schema is your entire declaration. You can think of it your entire files containing your types, your all your types, right? So you can see that here we have a schema that has different types. It has a query type. In GraphQL, a query type is a type that is um, let's say like a keyword type. That is, it's declared by GraphQL itself. You shouldn't try to create an abstract type that has a query that is a query. So query is reserved by GraphQL. So query, subscriptions, and mutation, those types are reserved by GraphQL itself. But aside from that, you can have custom types. Like we can see in the schema here, we have a custom type called character, we have a custom type called planet, and we have a custom type called species. So what is a schema? A schema is the blueprint of your GraphQL API. So a schema defines all what your GraphQL API can. All right. So schemas define a hierarchy of data types with fields that are populated from your backend data store. Schemas can be defined first or generated from code. So if you're using something like some libraries, like maybe if you're building a GraphQL API with something like Nest.js, you could either choose to generate your schemas when you after writing the code. So you can finish, or you can write your code and declare your relationships. And automatically, Nest.js using GraphQL, some GraphQL libraries, they will automatically generate a schema for you. So you don't have to manually type the schema. All right. So that's called a code first approach. We also have the schema first approach where you yourself you go into you create a file and you start defining these types. All right. So and in today's demo, we'll be going with the schema first approach where we will define our types and then create resolvers on how those types should or how the GraphQL API should respond when a request is made to fetch data of those types. All right. So these things like okay. So finally, we'll discuss the query. I think there's still more, right? So we discussed the query. We'll still highlight this while doing the demo, but because of time, we're just trying to go through all the common terms. So we all get used to it. All right. So a query in GraphQL is simply a way to fetch, retrieve data from a GraphQL API. Right. So you can think of a query like a GET request. Whenever you're making a GET request to your REST API, you can think of it that's almost the same thing as when you're making a query in GraphQL. So you just need to fetch data, you're not mutating data. Okay, so next, okay, I think this is a query. This is also a query. Okay, so I think I duplicated the slides. Let's go over to the next thing, which is mutation. So mutations in GraphQL are used for creating new records, updating existing records, deleting records. So you can think of it like your post and your patch and your puts in REST API. So whenever you want to do those operations that mutate data or create new records, you use mutations. All right, so that's just the difference, and these are most likely likely the types or the things you'll be doing with an API. You're doing your CRUD, you're either creating, you're reading, you're updating, and you're deleting. Okay, so for the reading, that's handled by your query, and for creating, updating, and deleting, that's handled by mutation. Okay, so finally we have subscriptions. Subscriptions are just like um, WebSockets or sockets connection. So subscriptions allows you to have real-time events. Maybe you want to build an app where when someone sends a chat request or sends a chat, it automatically shows up on the other person's end or whichever client is connected. So if you can think of it, if you've used socket.io or any WebSocket implementation, you will see that um, that's the same thing as subscriptions when it comes to when it comes to GraphQL. Okay, so next we'll discuss resolvers. Resolvers are just they are essential parts of GraphQL server implementation as they define how to obtain the requested data. That's a keyword. Yeah, they define resolvers defines how to obtain the requested data from the data source, which could be a database or an external API or any other data service. All right, so you could think of it like, okay, a request has come, this person has made a query to fetch data of this kind. Resolvers are just like functions that looks at the request and says, oh, okay, this is how I would fetch the required data or the requested data. All right, you could think of them like services or controllers when it comes to REST APIs. All right, so the
Okay.
act, yeah.
Sorry, could we say resolvers are like handlers? Like when you have data come through, you want to have a way to handle that. Like you want to go to the database or calculate a term or add two numbers or something like that.
Yeah, yeah. So they are also handlers. These are all depending on how the backend is structured. Some persons they will just have resolver sitting as a middle man there, and they have different methods in a class that defines those business logic. Right. So you could just call them as a handler, just like your routers in when you're building with Express.
Okay. Oh,
All right. So they act as a bridge between the GraphQL query and the underlying data. So resolvers, you could think of it like the query comes, the resolver thinks, looks at the query, and the resolver is able to say, "Oh, this is how I would fetch the data." Definitely, every backend system is persisting data somewhere, either in a database or in a different API entirely. Okay, so we've finished. We've discussed about GraphQL. We've looked at certain keywords, we've looked at the types, we've looked at the queries, we've looked at mutations, we've looked at schemas. So next, now we need to do some demo. We need to try to use this thing. So you get you get a complete feeling of what it's like to be building with GraphQL. So we'll be building an inventory API with Apollo Server. Okay, so Apollo Server is a very wonderful library that offers a couple of tools needed to work with GraphQL. So Melody will be handling that section. So Melody, over to you.
All right. Thank you so much, Oliver. That was a very nice one. I really kind of, I think I learned more, quite a few things from, you know, from the GraphQL talk.
All right.
So we'll start by writing some code. So today we are going to be using SQLite because it's a very lightweight, uh, let's say, database, and it allows you the flexibility and everything. To start, please go ahead and uh, download the or clone the inventory application, the startup file. Is that the
Sorry, I
startup?
think Melody, I think your screen is not showing clearly. It's not covering the viewport here. So is there any way you could extend the screen a bit?
Okay, sure. How about now?
Yeah. Yeah. So then after extending, then you could zoom in.
Okay, let me get that done.
Okay. Yeah. So I think you can work with this.
Okay, this works better, right?
Yeah, this works.
Okay, so generally go ahead and check out into the starter project or clone the starter projects on GitHub. The link is on the screen, and we are going to be using SQLite and a couple of you know, packages. So let's go ahead and install that. One of the packages we're going to be using is SQLite 3. So we'll go ahead and uh, install that. So you can go ahead and include this in your package.json. We will need type ORM because we don't want to handle a lot of things ourselves. So go ahead and include this type ORM. And we'll need the reflex metadata for you know, type RM. So go ahead and install that. And once you've added those, you can go ahead and in an integrated IDE, let's go ahead and let the terminal run npm install. I think I saved this, did I? So go ahead and run npm install. While that is installing, let's go ahead and look at what we have. So we have an index.ts here, which is our basic index file here, and this is just uh, very basic here. So let's go ahead and delete all of this so we restart the entire process. Or you know what? Let's not delete everything. Let's just delete from here to here. So what this is doing is we are getting our Polo server and we are getting our standalone server. So I'll just delete everything and start. So that we have a clean sheet. So what we want to do
Okay.
is we want to instantiate a server, and we could do this. So we want to instantiate an Apollo server. This is going to be your type definitions. Your type definitions are your schemas, and we'll have our resolvers here. So for the now, uh, sorry, give me a sec. Sorry about that. So we have your resolvers, we have your type definitions, and we want to use our standalone server to, you know,
Yeah.
wrap around our server here, which is this our server instance we have here. So we'll go ahead and do that. So we'll have this, but we need to import this from somewhere, right? I think we have a okay. We have this installed, so we can go ahead and import our Polo server. So let's do this. If I put my cursor here, it imports Apollo server. I want to go ahead and import the standalone server. Now we have these type definitions and we have these resolvers. So we need to create them, right? Let's go ahead and create. let's go ahead and create our type devs first. Now, your type definitions are your schemas, right? So we'll go ahead and create something called a folder here. I will call that folder GraphQL, and this is where all our GraphQL stuff are going to live. So this will contain a schema, a resolver, and any other thing. So here we want to create a file called uh, let's call it schemas, right? So
Yeah.
remember, GraphQL has six schemas, and we're using a schema-first approach. So we want to create our schemas as well. If you're using something like Type GraphQL, which is a package, I think that's goes ahead, goes through your code, introspects your code, and grabs the schemas from your types by default. So you don't have to create your schemas. But here, we have to do them ourselves. So since we are building an inventory application, the so we want to have probably items, we want to have tags, we want to have supply, and probably want to have something like you know general input types or something like that, item inputs and stuff like that. So we need to so depending on how or whatever you want to use GraphQL tags to define your schemas, right? So you could use something called GQL tag, or you could use a GraphQL uh, tag. Like, let me show you. I think it's going to be easier if I just show you. So we want to export a constant called typedef, and this constant we could go ahead and use this backticks here, which is this backticks, or what's it called again?
Back
Can you remember?
six.
Can you?
I
Yeah,
think
I
it's
think
back.
there's a yeah, just one other fancy name. So we want to use
Okay.
this, and what we could do here is have GraphQL. So we have this GraphQL. Now it recognizes that, well, this is actually a GraphQL schema. Then we can start defining our schemas here. The first schema we want to define here is going to be our items. So what this means is, I think I must have messed up something. Okay, yes, I did. That was very funny. Uh, so we have items here. Our item is going to have an ID, right? And an ID is going to be of a type ID. Now, GraphQL allows you a type of ID, right? You could equally use an integer if you want to do that, but we're going to use this type ID. Our name is going to be a string. So our item is going to have a name, which is a string, a description, which is a string, an image, which is a string. So what you want to regularly do is you could pass your image if you have you have an image passer, you upload it to S3 bucket or something like that. And when it resolves, you could grab the URL and you save in your database here. We're going to have tags, which is going to be an array of a type tag. And this type tag, we've not created it. So let's go ahead and create that type tag. So create a type called tag, and this tag is going to have an ID, a string. I created that, which is a string, an item, which is of a type of items. Now, over here, we have a category, which is of a type category. So these are your custom types, right? And you want to create a type of category. You could see this as a in TypeScript. Well, you could see this as a what should I say? Uh, Totally forgotten. So I think these are your custom types, right? Where you could see these are not really enums, but like your custom types, and you could define whatever you
That's
want to
your
have.
abstract types.
Yeah,
Yeah, that's your abstract type.
yeah, your abstract types. So I was looking for the an equivalent in TypeScript. That's
Okay.
types, is types and interfaces, right? So you could see these as probably types or something like an interface where you have different
Okay.
definitions and stuff. So
Okay.
category here, we want to go ahead and create that category. So a category is uh, going to have an ID, a string. We created that a string, an item, which is of a type item here. Now, I think okay, let's because I want to explain an instance here. So I'm going to go ahead and create a supply, which is of this type here. So remember when we say GraphQL allows you relationships, right? So you can see that here that we have an items which has tag, right, to it, and we have a tag here which have items to it. So this is the kind of relationship that GraphQL allows you. So what it means is that with this we could resolve this in such a way that, well, we could query for an item and get all the tags in that item. Or we could say, well, I want to start with tags and I want to get all the items in that tag. So it allows you a bi-directional flow of data. So it's not really the straight up rest where you have, here is your data, this is what you have. GraphQL is like, okay, if there's a relationship, if you define a relationship between a tag and an item, well, you could query it however you want. I don't care, right? As long as you have an item here, and a tag has items, a list of items, and an item have a list of tags. You could query it however you want. So here I could come and say, okay, I want give me all its items on this inventory app. You know what? Give me all the tags in each item. Or I could say, give me a particular item with an ID, and that item I want to go ahead and grab the tags. And it doesn't just end there. I could go ahead and say, in that tags, I want to go ahead and grab the label, the created art, or I want to go ahead and nest it and grab an item again, right? And that will resolve to an issue. You see that GraphQL equally comes with an issue where you have to deal with. Well, you could nest your data to, you could say, okay, you know what, I'm going to run in a loop here, grab me each item, give me their tags. In that tag, grab me each item, give me their tags, grab me each item, give me their tags. So you have to come, that's where creativity comes in. You have to solve issues like an M+1 issue, and you have to equally solve issues where you have to give limitations to the level or deepness of your queries, right? So here we have this, and let's start defining our mutations. So remember, our mutations are generally, should I say, methods that modify an instance. So some of the mutations we want to have are, we want to have the add tag mutation, we want to have the add item, we want to be able to add an item, and some other things. So let's do that here. So we have here an add tag mutation, which has an input of label, and that label is going to be a string. And this here means that it's going to be required. So if you don't supply a string, GraphQL will not even allow you to run this. And what this does is, in the front end where you're using a package like an Apollo server for client, Apollo's client, if you don't include your string here, well, GraphQL is going to be like, well, that's not right. I'm not even going to allow you to run this query at all. So you can't even hit the server because you're not meeting the requirements. And that way, you don't have to worry about, you know, passing your
Validation.
DTOs and, yeah, validating and stuff like that, and validating your data transfer object and be like, okay, this data, I want to check if this, go ahead and write this and stuff like that. So we don't need to do all those extras because GraphQL is ensuring that that data must be there. If you're defining it to be required, it's going to be definitely required. So here we have an add item, and we're saying that we want to have an input. Well, this input is going to be of a type item inputs. And this item inputs, I think we've defined somewhere at the top here, or we haven't. So let's
No,
go
we have.
ahead and define an item inputs. So we'll define an item input somewhere at the top here. And we can go ahead and define our queries as well, just so we have that. So we can define our queries. Some of the queries we want to run are, well, if I call a tag, you should grab me all the list of the tag. So this is an array of tags. So just go ahead. When we write our resolver should supply an array of tags. If I call a categories, grab me the array of categories. If I call a supply, grab me an array of supplies and stuff like that. So remember, your queries are like get methods, and your mutation is like all the modifiers like post, put, patch, and all that. So here we equally have our delete tags here where we supply an ID and all this. Now, by default, if you have this way, GraphQL is not going to know what to do because, well, GraphQL is seeing all this, but how do we save our data, right? When we say add tag, where does our data save and all that thingy, right? This is where we have to resolve each of these schema. So we could resolve that, okay, for our query tags here, we want to resolve what happens when we call a tags here for our query, right? So first off, I want to go ahead and import this because we can. Oh, we can't. Awesome. Okay. Yes, we can. So I've resolved this, and let's go ahead and create. Uh, no, let's go ahead and create a bunch of types here where we're going to use. And the reason we are not typing all this out is, well, this some of these things are pretty much straightforward, right? And we don't have to start writing, a bunch of files and stuff like that. Some of these things are pretty much straightforward like this. Here we have the types in GraphQL. You define a custom type, which is a scalar type. You define a custom type here, which is your tag. And these are your, uh, these are your scalar types, and these are your abstract types, right? Where you have, well, this comes with GraphQL and stuff like that. So let's go ahead and create types. So these types are going to be what we use in our resolver, right? So in our
Yeah,
resolvers, yeah,
like
we
your
want to type
TypeScript
our
types.
arguments, yeah, in your TypeScript files. So let's go ahead and create that in here. So we'll call these types.ts. And I'm going to go ahead and put a bunch of types here. So these are a bunch of interfaces here. This is regular TypeScript, nothing GraphQL, right? We could even take this out, but for simplicity, we want to have it here. So we have an interface of item tag args, and this is your tag argument, right? This corresponds with what we have here, right? Since we are writing TypeScript, so we have that in our mutation here, add type here, we have a label that is a string and is required. In our TypeScript here, we are saying that, sorry, in our TypeScript type here, we're saying that we have a label that is required. If it's not required, we'll do something like this. But because it's required, we are not doing that, right? And we'll have a bunch of other arguments like this. This is add item args, and this corresponds with our schema here, where we say that add items is going to be of an item input. And if you look up here, this item inputs will have a name, a description, image, tags, uh, categories in supply, and this corresponds to what we have here. A name must be required, and description, a tag must be required, and images, an image must be required. A category is optional, a supplies is optional, and that is what we've defined here as well. This is okay. I think in here
You
we
missed
didn't
the
actually
required there.
specify. Yeah, this is not. We didn't specify that this is required here.
Yeah,
To make it
yeah,
required, we have to put it this way, right? We could use
yeah,
this, but I think TypeScript got us covered as well, but we could just do it. So on the GraphQL end, we are always requiring that, right?
yeah.
So we could say images was required, tag this is optional. I think that's optional, right? Here, tags is optional, and just this to, okay, tag is required. So we could say tag is required. So you must provide a tag if you want to create an input type, and these are optional. So now we have that off the way, we can go ahead and create a basic resolver file, right? So we want to go ahead and create a resolver file here. So we'll call this resolvers.ts. What else could we possibly call it, right? So in this our resolver, we want to call constant resolver. Okay, awesome. But no, I'm not using that. So we want to call a constant resolvers, and we want to go ahead and do something like this. Now, in this our resolver, we are going to have a query, right? We want to resolve queries, and we want to resolve uh, mutations, right? Remember, you have your queries and you have your mutations. So I'm not spelling this wrong. I think mutation, that's correct. Mutation, yeah. Okay, of course, I didn't add this. So we want to resolve our query, we want to resolve our mutation. So one of the queries we want to resolve is the items query. But before we do that, well, we want to create an entity or model for our different schemas, right? So we have an items, we have a tag. We want to create entities or models for those that corresponds with what we have on the uh, that's the ORM. That's the type ORM. So we'll go here. I will create an entity,
Yeah, for the
and this is
database.
type, yeah, for the database, and this is very type GraphQL type ORM specific, right? This has nothing to do with
GraphQL.
GraphQL. This is just your database connections, right? So we'll call these entities, and there we have it. So one of the entities we want to have is the tag entity. So go here and create a tag.ts, our tag entity, and our tag entity. Well, what we just want, we want, what we basically want to have here is, if you go to your schema, you're going to see that your tag here has an ID, a label, a created art, and an items, and those are the things we want to have, right? So when we go to this tag here, we want to go ahead and create that as well. So we have an entity, an entity decorator here, and this is very type ORM specific here. So we are saying that this ID here is going to be a primary generated column. So auto generate it for me. I don't want to supply this whenever I'm creating a tag. And here we are saying that this is a column. What it means is that the user is going to provide this data for you, right? So this is actually a column. And here we are not saying this is a column. So well, TypeScript, sorry, or type ORM, go ahead and figure out the creation of this created at here, right? I think are we messing something up?
Yeah, so
Yes.
TypeScript will automatically supply at that column, and then whenever you're creating a record, to use the current timestamp to create a created at time. That is, the created at time will automatically be populated once you're creating the record.
Okay. Awesome. So I think we're having something wrong. So let me see. Or could it just be my TypeScript
Okay, just
messing up?
save. Maybe is it linting?
Probably because
Just
I've
save.
not
So
actually. Yeah, I think
have you installed
it's
all the
not linting.
packages?
I believe so. We've installed all the packages. So we have a type ORM installed, SQLite, GraphQL, and Reflect metadata. So I think probably when we link this to our type ORM composition, it could
Yeah.
stop warning
Let's
us.
hover and see. Let's hover and see what the error is. So let's
So unable
hover.
to resolve signature property decorator when called as an
Unable to
expression.
resolve signature. Signature. Okay. Let's just continue, and uh,
Okay.
we can
Just
reload TypeScript.
yeah, sure, we can. Okay. So we have these tags here. The next one we want to create is our items, right? Our items of TS. So go ahead and create uh, items item, right? Because well, it's one item. So item.ts, and we'll go ahead and put the items here. And what we are basically doing here is the same thing. We are going to create because an item has a tag in it and it has its supplies in it. We're importing those from here, and we'll create those in a bit. But we are importing those from here, and we are saying, well, you can see there is a relationship here. A tag has a many to many relationship with an item, and what this means is that an item could have many tags, right? And a tag could have many items, right? And we are doing a join table, so we are joining the table. So when you query, you can have that flexibility. And this is regular SQL, right? But type ORM is an overlay on the SQL. So these are your regular SQL. The same here. Your tags is like an array. Is going to be an array, right? Like this tag here is going to, or this tag here is going to be an array of the table tags, the table tag, right? And we'll have a many to one relationship. So we'll have here that category, well, which is very optional here, is going to be, uh, you know, of a type category here, which is this field here, which is this entity here. So type ORM will go ahead and respect those. So when you're using type ORM methods, type ORM knows how to handle those. those, right?
Let's
And
try fixing these Google lines. Is it possible? Like,
yeah,
so if you go on the terminal, if you go on and open VS Code, just you hit command and P to open the command, like the command palette thing, and then you add an anchor bracket or something and reload TypeScript.
okay. So you want me to open this terminal
No,
section
no,
again?
not the terminal.
Okay.
The how do I? So the command window on VS Code where you could search for files. Like when you do Command P,
Yeah.
just once you do Command P, and then have um, arrow
Okay.
forward
This
arrow
forward arrow.
forward arrow. No, no, just forward arrow. Just the arrow key that points to
Your
towards the
forward
left.
arrow. Okay.
Yeah. Then you do TypeScript colon
Okay.
reload.
Put TypeScript. Okay. TypeScript.
TypeScript. Yeah, so
And
TypeScript, you
this
see
one.
reload, yeah, reload project.
Okay.
That's supposed to fix that if it's actually a TypeScript problem. So what's this is saying? Okay,
Unable to resolve signature.
so let's ensure the packages are installed. Can you just do npm install again?
Yep. I will do that now. So we have a type RM this. Let me go ahead and save this one more time. And you know what? Let me just check if we have our node modules. Okay. We do. So I'll go ahead and open this. Okay. I think we do. And nope. So how about I try closing this and restarting if that will fix our
Okay,
issue.
save it and then reopen VS Code.
Okay, let me save that. Save this and save this. Let me save it.
And then reopen.
I think I have one saved file here. After the JSON. Okay.
Yeah, maybe you just try closing VS Code entirely and then reopening it back.
Okay. So
Okay,
let me spin that up again.
yeah.
It's weird that we have the same issue. Very weird. Because I know that this is how to use type ORM. I'm pretty sure
Yeah.
about that.
So what version of Node are you on?
Yep. That's another one. So let me see. Let me see. Anything?
You're on 18. Then
Yep.
this should everything should work fine if it's 18. Uh-huh. This is okay. Let's be our debugging hat.
Okay. I think
Okay.
probably we could try what we could try is no hold on a sec. Let me just try this. So let me move this out and do at entity and decorator and go ahead and do
Add
so I
export.
think yeah export class class tag. Okay, so we want to export this and then it squiggles out again. Okay,
Is it working now?
nope, it's not. So I okay. So my guess is probably type RM is just requiring us to have the type type RM instantiated. So let's go ahead and do that real quick. So let's do
Oh,
one.
okay. So the type RM does JSON file.
Uh, yes,
Is it
or more
okay?
like the data source.
The data source. Oh, the data source. Yeah. Okay.
Yeah.
So let's
So
have the
let's
data source.
okay. So let's do that here. I'm going to create that on here. So I'm going to do a data that source, right? .ts, and we could go ahead and create exports tons uh, app data source. Awesome. And we could call a new data source from type rm, a new data source, and call this. And here we could have our type to be, to say our type is of a SQLite database is going to use a DB somewhere else, data, then inventory API to synchronize this to be synchronized through login, just so we are seeing our logs. And I don't know why my LinkedIn is turned off, but this is killing me.
Okay. Your LinkedIn is not
Okay,
working.
no, it's not working. I think my pigments are just failing me today. So we can go ahead and import uh, for our entities. We could go ahead and import this. So say entities. We want to go ahead and import our tag, right? Uh, from here. We want to equally import our items, right? Item. So let's go ahead and see if that fixes our tag. And it
No.
doesn't. It
So can
doesn't.
you put your cursor there and press command control and press control dot to like let's see if we can see this thing. Just control and dot.
Yep.
Okay, it's not even getting it. Okay, just remove the imports from type RM, the imports from type RM. Just remove all the imports, like all the import section, and try to import it with command and dot.
Okay. I think that's command space.
Yeah, command space. Yeah, hit enter. Delete.
I don't think that should work because then we did that initially and
So why is
we
it doing this? Hover again. Let's read through the error. Hover on it again.
unable to resolve signature or
If
property
not, repeat
decorator
your
when format expression. Argument of type field. Tag. No no. Okay. Private is not assignable to parameter of type string. So I think we are having a type wrongly here. So we're saying that the ID
No, it's not even all the way from at entity declaration. Like things started going the other way. I don't know if it's from settings on your VS Code, specific to your
I
VS
doubt
Code.
I don't think it's a setting on my VS code.
Okay,
Right? I
so
don't have any.
let's review the versions of package store
Okay, so let's review
that was
those.
installed.
So have the uh, SQLite CypherRM
You know,
0.3.17
SQLite reflect
reflect.
metadata. Have you added the type TS config properly? Like, look at the TS
Oh,
config.
that's true.
So update the TS config.
Yeah, we may need to update that. That's awesome. Oh, that's awesome. Okay, so let's see. Yeah, we're not pointing to the root files and stuff. Ah, that's now I feel crazy. Like I feel like, oh god. So we need to point our base routes and stuff. So I'm going to get this from here and add it here. I think that should resolve our issue.
Yeah,
We
so
have
you just
the,
have to go back there and refresh or something. It
yeah,
has
it does.
resolved it.
It does automatically. Yeah.
Wow.
Oh, that's it's crazy, right? All this was TypeScript all the way, and we're like,
Yeah.
Was it a file import or something? It's really crazy.
Yeah.
All right, let's go ahead. Well, this is what you face in a real life, or in a real life code section. I think. If it was, yeah, it's crazy.
It was
So
pre-recorded. This part will just be cut off.
yeah, and you'll never get to see it. But here
Yeah.
we do everything live, right? And Fizzbox
Yeah.
live. So we have
Okay,
a
so let's
category.
get the rest of first.
So we want to go ahead and create a category. Because we've spent a lot of time, we are going to create that, then explain probably later. So create a category .ts, and so let me grab the category file from there. So generally a category, and most of these things are going to, in fact, not most, all of them are going to correspond with what you define in your schema, right? So your schema is, uh, is going to tally with what we have here. So you can say, in here we'll have a category that says, well, there's an item here, and it means that if I go ahead and remove this out, I cannot query for this. Like I can't query this category here. It's not possible. Like I can query these items in here because it's still in the database, but it doesn't just function there,
Yeah,
right?
it's not exposed.
Yeah, it's not exposed. And if I go ahead and comment it out, well, it's going to error out because, well, you have an item here, you want to grab an item, but in the database there's no access to the item. So if you go to category and say, well, this one to many thing here, I want to comment it out. In your resolver, you're going to have issues because you can't call items, right? So here we have this, and the next one we want to create a supply.ts, and it's just an entity, so we'll just create a supply.ts, and nothing fancy here. So let's explain this just quickly. These are decorators. Decorators are like you see this as things that carry metadata, extra metadata into your code, right? So this decorator, when you add this decorator, it's going to carry all the entity metadata provided by type ORM into your code. That way, this can function as an entity, right? If you have this column here, it's going to carry metadata. If you look up here, you're going to see that this is an actual code, right? This decorator is an actual code that has a bunch of things under the hood, right? And this one as well is an actual code that has a bunch of things. So it provides you the option, and there are a whole lot of things here, name, order by, and stuff like that. So these carry some metadata where you don't have to provide those by manually typing them out, right? And we still have one error here. So we're having this category here, and I think we spelled category wrong, or haven't we? But because we know better, we'll just do this and import this from here. I always mistake it because I use a Windows and a Mac. I always use the command space. Then I realize
Yeah.
what I meant to.
Let's
It's
scroll up
crazy.
and see how the import looks. Okay, cool.
Yeah, it's imported. All right. So we have this. Next, we want to deal with our resolvers, right? Because here we want to start handling these things. Or before that, we want to go ahead and I think we've initialized our data source. So let's look at our index for a few minutes. Okay, we've initialized this. We are calling the type def and everything. For that, you'll need to connect to a Wi. But
So we need
then
to
we'll have to
initialize.
initialize. Yeah, we'll have to initialize our database. So we'll have
Yeah.
our app data. So we'll call our app data source. I want to initialize. So we'll call the dot initialize, and it's that simple. And well, what happens then? Want to handle this dot then, right? Okay. So when this
Promise.
happens, we want to say dot then, which is a promise. And when that happens, we want to, well, we could have a console log here that says this is now database initialized or something. So we have this uh, console log db up and running. So db up and running. And we want to handle what happens when an error. We want to go ahead and put that. on the console as well. So we'll say dot catch when there's an error. We want to catch that, and we want to go ahead and do this console dot log or error. Want to log the error, right? That way we have that there. So we've initialized this. We're just handling errors and when the database is running and nothing fancy. So I'm just entering a new line here. So just when this console, when this logs, this is equally going to log. So I just want to have them on different lines. I think at this point we can start our application. Can we? Let's try it. So
Yeah,
let's try
we
starting
can
this.
start. You're yet to save the data source. I can see the mark there. You're yet to save the data source.
Oh yeah, that's true. So we can see. No, I don't. Oh yeah, I
And
think I made a modification.
you've not done importing all the entities.
Yep, we have a supply and we have a category. Thank you for that.
Yeah.
So we have this. So let's try npm stats. I think we have a start script here in our package.json, as you can see. So in our start here, we're saying npm run compile because this is TypeScript. We want to compile that, and we are going to compile that. It's going to first off, when you run compile, it's going to use TypeScript and compile that into a this folder. Then we want to go ahead and say node starts node on this folder. So that's what that does. So when we run this, it's going to compile this, run tsc. This compile here tallies with this. So it's going to run tsc, put that in this folder, and we can have this running. So I
Okay,
think we'll have an
we've got
error.
an error.
Yep, let's read that.
Let's see. Export is not defined in ES model scope. So where did you do the export?
I think I use export somewhere.
Okay.
Aren't we providing
No, that can be fixed. I think it's in one of the files. So if you go to the files, index.js or something. So
okay?
not index, so scroll up. Let's see. Scroll up. Maybe it's up. Not here. So let's look at the
Yep.
error and see what file is showing the error.
Okay, I think it's
Entry
package.js.
type module. Okay, remove. You need to
So
update
yeah,
that module. Remove that module type in package.json.
yeah, we want
That
to remove
module
that.
declaration.
Okay, so in our package.json, we have name, main, where is it? Here.
Scroll up. Scroll up.
I don't think we have
Oh,
that here.
type module on line 13.
Okay, yeah, we're defining this type to be a module. So what this
Yeah.
does is it's going to allow you the other way where you have to do the the
Requires.
non ES6 syntax. So you don't use the modular the module uh, JavaScript, right? So you're writing instead of export const, you're writing uh, what's that called again? Uh, I totally always
Require.
forget. Is that no export dot something? Yeah, and you have to use the require and stuff like that. You can do import and all those things.
Okay.
So I think we should be good. Let's run this again. Clear this. Run this. And nope, we have a
The
resolvers here.
resolvers issue is a resolver. Resolver
Yep,
is
in
not
our,
defined.
yep, we don't
So
have
how was
this
it
resolvers.
imported?
Let me see. Let me see how that was imported.
If not,
Funny enough,
you're yet to import
I've,
it.
I've not imported it, and I'm trying to import it. Oh, am I? Yes, I am. No, I'll just do that manually. So I want to import resolvers. I think I'm not exporting resolvers from
Oh,
here. So I'm calling the cons here. So I would export export default. Let me just export as a default. Uh,
okay.
that way we use it in here. Awesome. I always hate when I use the autocomplete and it generates a bunch of things for me.
Disabled mine.
And I'm like, well, you suggested it for me. Why are you doing this to me, right? So let's try it again. Okay, so credits again. Game starts. Awesome. This is great. This is a nice news, right? I think with this we can go to localhost 400 and look at this, or 4,000 and look at this. So I'm going to open up a tab real quick. Okay, so I'm going to open up a tab real quick. Let me share my screen on that. That's weird. I have to stop sharing this screen and share this. Okay, so now you can see this.
Yeah. Can you zoom in a bit? It's a bit
Yes.
tiny from here. Yeah. So this is good now.
Yeah. Now what we can see here is this has been introspected for us. You can see here we have mutations, and we have all this. If I'm all this mutation here, so let me go back. We have this mutation. We have all this mutation, and this
Already.
was generated. This was composed from our schema, right? Our schema in our code. The schema we have. That's the GraphQL schema.ts, right? So all those things we declared in our schema are here, and we have our queries here. So far, we don't have any resolver for it. Like there's nothing resolving the query. So if we go ahead and call, so if I go to a query here and I say something like, you know what, let me grab the tags, right? So there's a query example here, tags. I'm grabbing the tags here. I'm grabbing the category as supplies. So you know what, let me just call for tags and execute this. Well, this returns null, right? Because uh, first off, I think I don't have a resolver for this, so this shouldn't even work. Okay, so there's no information there, so this is currently returning null, right? Because in our schemas here, we are having that in our schemas here, we are equally defining the return types for each item. So we are saying that the tag is going to be of a type tag, and category is going to be of a type category. And we are not specifying here that it's a required it must return a required type. So I share this real quick. I think I'll just share my entire screen to save me the back and forth. Okay, so I'm going to share my entire screen. So
So you just have to share the both screens.
yep. So I'm sharing both now.
Okay.
So what we are saying here is, well, if I go ahead and say this tag here is going to be required. So whenever I query for a tag, please make sure you're returning a tag for me here. And I think this auto reloads, if I'm not wrong. And
No,
I
it
go ahead and
doesn't.
query. It doesn't.
Yeah.
Oh yeah, we're using Node to start. That's
By
true.
just using Node to start.
So I'm going to restart this. Uh, all this. This is up again. So if I run this, now you can see an error here. It is because we don't have any resolvers for this, right? So by default, if I don't specify that this is actually required, GraphQL is going to be like, okay, you don't have a resolver for this, so your data is going to be null, right? And it's going to return a null. But when you're specifying that, well, this return type must always return something. So I'm expecting that this data should be there and it must return something. So this is like a step to even typing your data source, right? GraphQL is going a step to making sure that your resolvers are there and everything. So that way you're very much aware. So if I receive this, uh, go ahead and uh, explain this, we should see that this works perfectly well because it's now there's no resolver and all that. So let's go ahead and resolve uh, query, right? Let's go ahead and start resolving it. I'm going to,
So can you extend the screen so it's covering like the whole place, and then you can be sliding left and like make
yeah,
it full here. Yeah, exactly. Then zoom in a bit, like zoom VS Code.
yep.
Yeah, yeah.
How about
Zoom
now?
in, zoom in,
Every every time I say zoom in, I just use the wrong command. So
zoom in again.
okay, how about now?
Okay, I think this is workable.
Okay.
I work
So
with
let's
this.
start working on our resolvers. So generally, we want to have a query resolver and uh, want to have a mutation, right? So one of the resolvers we're going to have is a tags, right? And what we want to do here is, well, we want to go ahead and first of all, we want to have services, right? Our resolvers are like take them as controllers in your regular REST, right? These are like calling services, different services. So we are going to have basically something here called a service. Is there no way I can extend this?
You can turn it down, like minimize it at the top. Just open in editor.
Yeah.
Yeah, and then
So I can have services. So I have a tag service, right? So let's go ahead and create a service for a tag. So I could say here tag dot service dot dot cs, right? And that way we have a service called tag service. And in this tag service, you can define all things, right?
prod.
Everything you want from the
Yeah,
tag. Uh, for for the sake of time, I'm going to put this here and we'll explain it. So we have a tag service here. This is basically a class. So we have a tag class tag service, and here you're having an async method get tag. So what happens when you want to get tag? You want to call the data store get repository, and this is an inbuilt method in type RM, right? And there's a get repository in type RM, which is an inbuilt method. If you look at the documentation, and there we are passing this tag here, and this tag here is coming as an entity. So we are getting the repository, and the repository we are getting is this entity, this tag entity here. So that way we are going to get whatever is here. And we can get tags by ID as well. So here we are calling get repository. We are getting this. Uh, we are getting every tag repository, the tag repository. And what we want to do here is now we have this repository, right? We want to find where the ID equals this no, this list of IDs here. So this flexibility allows us to find several tags with several IDs. So we have uh, find tags. We could have several tags, a list of tags, and that way it's going to find all those lists of tags. So we want to find where ID is equals this list of IDs here. So this is your in method in your SQL. where you have where this is in this, right? So type ORM is going to handle that for you. So we want to get a single tag as well. So we are passing a tag which is a number here. And we're saying our tag must be a number. And here we're saying get repository a tag. We're saying find one here where ID. So where ID is equals this ID. So basically you're doing something like
All these
this.
ones are just, I think they're all generic to, they're just relating to just normal working with type RM,
Yeah,
interface API, and calling the repository and then querying it.
yeah. So there's nothing
Just
fancy here. It's just
yeah,
regular stuff here. So let's compose those. Let's get that. So in your this mutation here, you want to go ahead and
query.
grab that. So let's call your query here. So let's call a query. What do we call the query? Collegically help us. What should we call our query?
We
So
can call
let's
it get tags. So tags, yeah, tags.
okay. Let's call it tags.
Yeah,
Async, which is going to be an async. So parameter. What are we passing? Are we passing anything when we want to get a tag? I
not
don't think
really.
so. So we're not passing anything here. And we want to call a return. So we could say a cons whatever, but we just want to return tag service, right? So we want to say tag service. Now there are methods in that tag service. We want to call on the uh, get
Get
tags,
tag.
right? And is that accepting a parameter? I don't think it's accepting any parameter. So yeah, so we call this get tags, and this should work for us. So that
We need
way,
to await
though,
it.
yeah,
You think it returns a promise, so we need to await it. So after the return, we need to add an await
yes,
there.
yes, please. I think sorry about that. So we are waiting this because well, this is going to take some time to get that data from your database. So you want to await that
Yeah.
whenever it's available, you want to return that. And we could do a bunch of other things, but we could do other one. So we could say get tag by ID. But this is not in our query, so we want to check if this is in our query here. So in our
No
schema,
schema.
so let's see what we have in our schema. We have tags. So we don't have any specific thing here. We just have tags.
Yeah.
So we can go ahead and we can add one here called get tag by IDs, right? And say this is going to be a list of tags, right? That works as well. And did I input something? So sorry, I'm trying to find that. So we have this. This is going to be a list of tags. Then we can start calling this. We can do something like get tag by ID in our resolver here by IDs, and this can be an async method. And here we could call a parameter. So we are going to pass in, and here we'll start defining a type for it, like right. We call IDs, right, and we could define a type for IDs, which is going to be an array of IDs, right, and all those. So we can come here in our types here and start defining those. But I think we don't have to do that for the now. So let's go ahead and create another. Let's go ahead and create a mutation instead. In our mutation here, we want to create. Let's create an add tag mutation. So I'm just going to put this here and we'll explain what this does. So there's an add tag here. So the way our mutation work is okay, we are exporting this as a
Default.
default. Makes a lot of sense. So that's why we're having this. You know what? I'll just have this way. Or
You can use it. It's just casing. Yeah.
it doesn't. It's not like case sensitive.
Yeah.
And thanks to my linter. So what we are doing here is well, we have an args here, which is an argument. This first data here, if you look up here, graph here. So this first data here, Clutch, can you remind me what this first data represents here? I think this is
Okay, so that's the parent. So whenever the resolver is getting called, the function that handles it gets passed some argument. So the first argument is the parent. So GraphQL has nest. There is nesting in GraphQL query resolution. So that's the parent, which is whatever argument that was passed, whatever data that was returned from the previous resolver. Right. So the next argument contains the args, that is whatever is passed to the current query coming to this query. Like whatever is passed, maybe you want to create a tag, whatever the name of the tag that is passed. All right. So the next argument that gets passed to that function is now the context.
Context, right? Yeah,
Yeah.
where you could get the info and all those stuff.
Yeah.
Yeah. So this is generally a parent, as Kelechi has explained, right? So the parent calling these values. For instance, when you're calling tag, this in your when you're calling probably a tag from a different resolver or something like that, your parent is just this one. So you could, in case there are some cases where you want to know the parent and do some manipulation from the parent, probably try the parent ID and stuff like that or something. But for this case here, we're not doing that. And this one here is your arguments, right? Whatever inputs data is coming through, you could call this inputs, you could name it whatever. For this case, we are calling it args here. And I think this args corresponds with what we have in our schema here. So if you want to change this here, you have to equally come here and change it here. So, okay, doesn't matter what we call it here. So we call it label here, and that label is going to be passed in as an arg here, right? So in here, we are destructuring this value from arg here. And you can see that we are not doing something like if this data and stuff like that, if label, go ahead and do this. And the reason for that is because GraphQL is by default going to be typed. Like we are typing and we are saying that, well, this is already required here. So this is very required here. So we don't have to check whether this data is available or not. We are very certain that if this code gets to this place, that data must be available. And whatever we get from that label, we could equally do some destructuring here from here. We just do something like label here if we want. That way we'll have to bypass this and that will be a shorter hand or whatever works, right? And we could go ahead and say, well, await tag service or create tag, and we're passing that label. And here we have this, and this is going to return tag because we're saying that in our add tag, we have a return type which is of a tag, right? If you look up here, our add tag is having a return type which is of an item actually. Sorry, of a tag here. So it's going to return a tag for us. And if we remove this, if we say this is something else like let's say I don't know, should we say something like strange or something like that? So it means that you can return a tag here. You have to return a strange in the end in your composition in your resolver here, right? So let's test this out. Let's add a tag. Uh,
You've not saved.
I have saved actually. Okay,
Oh, okay.
it's
I looked at the screen and it was still showing the white dot.
okay. So let's do that. Uh,
You need to
so let's
restart
call.
the server.
Oh, why didn't you just use why didn't you use why didn't we use what's the name? Why didn't we use the node one just to save us this stress? Okay, so we're going to restart the server. And this is why you need Docker in the end, not just Docker. This is why you need orchestration in the end, right? Imagine when you're going to restart your server every time as a DevOps engineer. That would be a headache. So you need to automate things and stuff like that. So with that done, we are going to run a start and we could do this. In the middle of this, my awesome mouse just died. So awesome. So I think we could call a type a
Can you zoom in a bit?
yep this. But no,
Yeah, perfect.
okay.
You can close all the windows. Yeah.
I think inspection query failed. Something happened in our resolvers.js. We are doing something wrong.
Okay, scroll up. Let's see. I think it's from the import. Scroll up inside resolvers.js. I saw it. So where you see that source, we have to
What would you like to know about Codasort?
let's use absolute import, not
Okay.
let's use relative import
Yeah,
rather with the dot thingy.
that's
Yeah, so you don't need the extra slash.
so. Let's
Yeah,
try
so
that
we can
again.
start thinking.
Okay, we have this now. So we call a mutation, mutation, and we could name our mutation. So what do we
No, you're
call this
typing
mutation?
inside the variables portion of the playground.
Yeah, I think I'm way zoomed in, so I can barely see that.
Yeah, yeah, that's true.
So, anyways, these variables is where you could provide variables like. I think we should just use this. So when we call mutation, and there's a suggestion for you, so that's nice. Mutation, we could call these tags,
Add tag.
tag mutation, tag, and here we could call add tag. So here we are calling this, and that creates a label for us, which is a null. So I want to call this. So our label is basically a string, right?
Yeah,
So what should we call this label?
food. I like food.
Yeah,
Food, food.
I know that's awesome.
I think you use double quotes.
Yeah, use double quote on this. So food, and here we'll start returning things because we want to return something. We return the ID, we return the what else? What do you
Label.
have here?
Let's return those two and the created ads.
Okay, we have the
My time is
label.
running so fast. And the
Yeah,
created ads.
can be created at. And you see that we didn't specify created at, but that gets generated for us by type
Like where?
warren. Yeah. So let's call this add tag, and it adds it here. So when next we run our tags here, so we could have let's have a query here, and let's query for uh, tags here. Let's call a query
Get
uh,
tags.
get get tags. Uh, you don't have to name this. You don't have to name this here, but that allows me to use multiple of these on this playground, right? So we could call get tag by ID.
No, we have tags.
We have tags, and we have to
Yeah.
get the. I want to get the ID, which is going to be one. I want to get
Created
the.
ads. Label.
So let me just yeah. So get tags, and that gets that. If I add another one here, and I say let's say money,
Chocolate. Okay, honey.
and go here and okay, we've not added that, so let's go here, add that adds. So if we get it next time, it's going to be like there are two items, right?
Yeah.
And we'll have these two here. So I think our time is fast spent, and
Yeah.
yeah, yeah, it's fast spent. I didn't really expect that would take up a whole lot of time fixing bugs and things, but here we are. So that's basically it on this. If you want to grab the full code, I think the full code is on GitHub on the link in the description. So you could grab that from there, from the main repository. Take this one here. Yep. So this one here, you could grab the code on the screen and make sure you subscribe, guys. It's always very crucial. And I want to remind you that subscribing is very, very crucial. I have my monitor here now, so I'll be staring at you over here. So
All
what do you think,
right.
Kelechi?
I think it's good. I think we've at least we've provided some steps to go about it. I think all the rest of it, like adding more, you just have to go to the resolvers and add more mutations and add more queries, and then you'd see that you'll be able to whenever you call get tags by ID, you'll be able to like get the tags by the ID and all that. So let's just to demo like you could see that from the query here on the playground. If you remove label, you see that the return response from you'd see that you wouldn't get a label. So that's where we're saying you request for just what you want and you get what you want. That's how GraphQL works. So I think that's it. Everything looks good. On the repository we just shared on the master branch, you get to see a complete code just in case you want to try this out on your own and all that. But you see that GraphQL or Apollo GraphQL also provides a playground. This is called a playground. It has like you don't have to like build a front end. You don't have to like use Postman. You just need to go to the URL, localhost, whatever port your app is running on, and you're seeing an interface where you can test your backend application without having to build a front end or doing anything. Right. So that's a tool that most times you want whenever you're working on the back end. Right. It's super good. So I think that's it for me, and it's totally it's been good so far trying doing this and Melody.
Yeah, I think now we're talking about it. I think this just as an FYI, someone commented that this is actually a template literal. So this was what we were talking about. So yeah,
Yeah.
thank you for that. That's Go Full Stack developer. So thank you for that. So yeah, that's it for me. And just equally subscriptions if you want to do WebSocket things in GraphQL. I think sometime we'll have to talk about that. We could talk about something like federated schemas where you have to do something like microservices and all those things. But yeah, let's see how it goes.
All right. Thank you guys for today, and bye. See you all next time.
Bye. Take care, guys.